Okay, so I'll try to help you out here a little bit this way. So I'm looking at question number 11. I'm assuming this is the 11 you're talking about on page, it's on page 95 in that PDF version of the book. So they want us to do this algebraically and then support it graphically. So I know I can't divide by 0, right? So if I look at this question here, let me see if I can do this in this board without changing. So I look at the denominator, and I know x plus 3 can't equal 0. And I know, and I wrote equal to 0. I'm going to solve it for that. And I know that x minus 1 also can't equal 0. So I want to find out where they are 0, and then that'll exclude that number from the domain. So if I subtract 3 from both sides, I know x equals -3. And same deal here. I know x equals +5. So +1, I mean. So those numbers are not in the domain of this function. So what I'm going to see there is I'm going to see a vertical asymptote. I know I'm going to see something like it at, let's see, what is it, -3. So I know this graph isn't supposed to cross over that vertical line because -3 isn't in the domain. And the same thing in at x equals +1. So I'm hoping from past classes that you know that it'll look something like these rational functions look something like this. I don't know exactly at this point what it actually looks like. We'll learn about that later in the next chapter. But I know that it's got those vertical asymptotes going on. I do know I could think about, well, this crosses the x-axis at x equals 1/3. So that tells me that this red graph in the middle isn't quite right. So I don't at least try to get, let's see, 1/3 to be about here. Let's get this pen working, Dan. So I know where it crosses something in there. Well, let's see. All right, well, let's try it this way. So I know this graph looks something like this. That tells me this side probably looks something like this. And it won't have that piece there. But you'll learn more about that in later sections. But right now I know there's supposed to be a vertical asymptote there. I also know, if you think about, I'm hoping that from earlier classes you learned about some basic toolkit functions, and one of those is the reciprocal function. And with the reciprocal function, it looks something like that. It has vertical asymptotes, and the range is everything except where that horizontal asymptote is. And the domain, well, even that's not always true, but the domain certainly doesn't include where the vertical asymptotes happen. So it's looking like the domain could pretty much be all reals, at least for this part, except for x equals y equals 0. For this one, I'm thinking, I think it's the same deal. I think it's not going to cross, well, except it does cross the x-axis here. So I think the domain for this piece is all reals. I'm sorry, the range is all reals. Of course, they aren't asking us this for this piece. And then the domain will be everything except x equals -3 and x equals +1. And then you said you're having a hard time getting the graph to look like this. So let me clear this drawing here so that, let's see, clear all drawing. So what's important when you're graphing these rational functions in a graphing calculator is to use plenty of parentheses. So I put parentheses around the 3x minus 1 divided by, then do you notice the a double set of parentheses here? I want to make sure that whole x plus 3 and x minus 1 is locked up in the denominator. If you don't put those in, it'll take this and divide it by the first thing and then multiply by the last thing, unless you lock those up in parentheses. So then I don't know what you've done with these calculators. A couple of easy ways to set the window is do zoom 6, and this is what my calculator is showing. And now I'm hoping that this is what you're seeing is that that you're confused about is this vertical line here, and how it doesn't quite do it right. This is part of the resolution problem on the calculator. We know there's a vertical asymptote at x equals -3. We know there's a vertical asymptote at x equals 1, and it's the computer's not figuring out that it shouldn't be graphing there, so it tries to fill in the gap. So we do know that this vertical asymptote, there's a vertical asymptote there, like we expected. We know there's a vertical asymptote here, like we expected. I'm seeing it crosses at about 1/3, so that checks. I didn't check the y-intercept, did I? But we could do that later. So I'm hoping that's where your confusion lies, is that maybe you didn't use enough parentheses when you typed in the equation, or that you're just not seeing, you're not understanding that it is just showing you the vertical asymptote. If you went out and did this on Desmos, you'd see that it doesn't try to fill in the gap here. Okay, so hopefully that's what's the 19 you said was the other issue. So that's the same issue, I suspect, with a calculator. Make sure you put parentheses around the 1 minus x squared. What does this look like algebraically? Well, if we had to do this algebraically, and they don't tell us to here, but it's not that hard to figure out. If I go out to very large numbers in the textbook, they talk about the limit. Let's see, it looks like I'm still writing with a board here. I want to write with this. If we take the limit as x goes out to negative infinity, or the limit as x goes out to positive infinity, all that's saying is what happens when we go pick very, very large numbers or very, very large negative numbers. What happens to this graph? Well, let's see. For this one, the top number gets to be squared. So if I pick a big negative number, a negative big number like 1,000 or 1,000,000 or 10 million, and I square it, and in the denominator I'm going to get 1 minus a negative big number squared. So this becomes a very large positive big number over, and on the bottom it becomes 1 minus another. Again, it's a large number, much bigger than 1. So this basically becomes a big number on top. So like if it's maybe I shouldn't be vague and pick a number. What if we substitute in negative 100 and we square it over 1 minus negative 100 squared? Well, that becomes 10,000 on top, and on the bottom I'm going to get 1 minus 10,000, which is negative 9,999. Well, this is very close to negative 1, and as we get out further and further, smaller, like if we go out to negative 1,000,000 or negative 10 million, what's basically going to happen, these two numbers are going to get very close to the same. That tells me as x goes out to negative infinity, y settles down to this horizontal asymptote where y equals negative 1. And the same thing if we go out to a positive number, it'll work out the same way, because this is a positive, this is positive, still going to be a positive big number over that negative one less than that big number. So this tells me the horizontal asymptote is going to be y equals negative 1. But that's a little bit of an aside. So what's the domain, or what's the range? I think it's going to go to positive infinity, and it may or may not cross the line y equals negative 1. I'm trying to think, where would it be? Let's see. We know there's some vertical asymptotes going on. So I know that it goes out to positive negative infinity. I just don't know. That settles down to negative 1. I'm not totally sure. I'm drawing a complete blank this morning about whether it's going to actually cross the line y equals negative 1. I guess so. Then we'll resort to a grapher to figure this out. Let's see. Let's go to my calculator, and I'm going to go to y equals. I'm going to clear out what's there. So I'm going to do x squared, and I'm not going to bother putting a parenthesis around the x squared because there's no addition or subtraction going on with it. But I do need to do this. 1 minus x. In chapter 2, we're going to learn more about how these things work. So if you can't, if it's a little confusing at this point, that's okay. I mean, you can certainly resort to a graphing technology. So let's see, I think that's good. I think I'm going to do a zoom 6, though I already did that. Let's see, window, yes, -10 to +10, -10 to +10. So I'm just going to go with that. And it looks like, I mean, to answer my question about whether or not it crosses to y equals -1, it doesn't look like it does. In fact, it looks to me, now remember, these are those vertical asymptotes that we're going to ignore. And if you think about it, I mean, how can we know though they're there? Well, if you look at that, if you look at this function, doesn't that denominator factor to x plus 1, x minus 1? I mean, 1 plus x, 1 minus x, because it's the difference of two squares. So that tells me it's going to have a vertical asymptote at -1 and +1. So if we look at my calculator, let's see, we kind of can see that that's happening at -1, +1. So I would say the range is from -infinity to -1, and then from 0. I mean, we could probably trace it and see. Trace, does it actually? Yes, it does cross the line at 0, 0. Curve the x-axis at 0, 0. Of course, I kind of knew that, I guess, because if I substitute 0 into this, 0 divided by anything will be 0. So, yeah, so that would be the range. It would be -infinity to -1, and then from 0 to infinity. Okay, and we can do that with set building notation. I think they've gone into that already in the preliminaries. Right, one way to write that would be -infinity until -1, -1. And I'm going to assume that it's open at -1, and then from 0 to infinity. Okay, so I hope that's what you need. If not, why don't you give me a yell, and I'll be out at eTutoring tonight. Get those afternoon office hours too on the calendar if you want some live help. Okay, so I hope this helps. I hope it gives you what you need. Let's see, I got to stop this recording now.